Good morning, students. So, in the last class, we discussed about the limitations of Lewis concept and the postulates of VSEPR theory, valenzation, electron pair, repulsion theory. So, due to that repulsion, that specially a specified molecule, whether it may be water molecule, ammonia, if you take the example, it may be methane or any other molecule, they arranged in a certain shape so that VSEPR theory due to the repulsion they decides the shape of the molecule. Okay, so for that before going to the actual structures one table is there that actually tells about what particular compounds and its shapes, type of a molecule and its shapes. Okay, so listen. Remember, at least two bonds are necessary to explain the shape of the molecule because you know LICL, one bond is there. One is Li, another one is Cl. Wherever the direction you write, so LICL, linear, LICL, linear, so LICL, linear. So any direction, shape is linear only. So to explain the perfect shape, we require at least three atoms and two bonds. One is the middle atom. For example, H2O. Oxygen is here, hydrogen to be like written like this, then the shape of the molecule is bent or invertly like that. At least two bond pairs we require to explain the shape of the molecule. Remember that. Okay? So why? I'll explain now. Initially, I'll give a list of the type of molecule and their standard structure. So students here, type of a molecule. Okay, so the first one is AB2 type. A is the central metal atom, B2 is the bonded atom. So the shape is linear. When I write okay. So this is simply like a chart. So here I'll explain the structures there. Okay. So AB2 type, it is a linear structure. Okay. So because listen students, here the central metal atom A is there. This A is bonded to B. Okay. Here only two electrons are there and two electrons of A are bonded with the electrons of B. Understood? There is no any other lone pair of electrons here. Then the number of bond pair is 2, number of lone pair is 0. So example for this type of molecule is BeCl2, BeH2, MgCl2, CaCl2, etc. Okay, so I'll give only some examples. Understand? These are the example for this AB2 type molecule. How? So listen here. Later I will explain the examples. Okay. So the next one is AB3 type. Okay, listen, here A is there. So they are bonded like this. So this is trigonal planar or triangle in the shape of a triangle. Okay, so if AB3 type molecule is there, trigonal planar structure. Trigonal planar structure. Okay, so here, so students, one, three bond pairs are there, zero lone pairs are there. Okay, so example for such type of molecule is BF3, AlCl3, BH3, etc. For which type of molecule? AB3 type. So students, as I told you, here three bonds are there. So in the place of this, there may be a presence of one lone pair electron. Same, of course, this is triangular planar, trigonal planar only. In the place of, as I told you, two bonds are at least be required to explain the shape of the molecule. There may be a presence of one lone pair here. Then the molecule becomes A. B2 is the bonded atom. E is the lone pair electron. That is electron pair A, B to E. Of course, here also the structure is trigonal planar only. For these two, the standard structure is trigonal planar. But, so listen, without taking this lone pair electron, okay, so the structure is taken as inverted V, or you may call it as bent structure. So if you consider lone pair electron, both AB3 and AB2E follows the standard structure trigonal planar. Even though the shape of this type of molecule is either you may say bent or inverted V. Inverted V. Okay, so here, so students, two bond pairs, one lone pair. Okay, so example for such type of molecule is SO2 and O3. Later, I'll explain all these compounds with an example and with the structures. Okay, next. This is one type. Remember, once you reach two bonds, then you need not to continue with that. AB2, that is the final. As I told you, at least two bonds will require to explain the shape of the molecule. So the next one is AB4 type. So if one electron, one bond pair leaves, so that is AB3E type and AB2E2 type. So students here, if we increase one lone pair electron, one bond pair will decrease. So this is the last one of this type of molecule because here only two bond pairs are there. We cannot take ABE3. This is highly impossible. We require at least two bonds. Okay. So now here, this is tetrahedral structure. Tetrahedral. These three structures also follows the standard structure tetrahedral only. But based on this bond pairs, so this one is bent structure, this one is twisted T structure. Twisted T structure. So students here, as I told you, the bond pairs are 4 here, lone pairs are 0. Here bond pairs are 3, 1 lone pair. Here bond pairs are 2 and 2 lone pairs. So example for such type of molecule is, so for this it is CH4, okay, SiCl4, okay, NH4 plus, okay. These are the example for this type of parameter. So this type, that is NH3, PF3, ASH3, etc. Okay. Next, so this type H2, H2S, etc. Okay, this example, sorry. Okay, so one AB2, AB3, AB4. Next is AB5. So students, this AB5 also written as AB4E, AB3E2, okay, AB4E3, AB2E3. Right? AB5, AB4E, AB3E2, AB2E3. So here the standard structure is trigonal bipyramidal. We're getting trigonal bipyramidal. So students here, this is also trigonal bipyramidal, but the shape may also written as square planar. Later, you just be with this chart. So while explaining the structure of those, I'll explain why this is trigonal bipyramidal, why it is square planar. Okay, so this AB3E2, that is triangular planar. Okay, this AB2E3, it may be linear. Okay, so here the bond pairs are 5, lone pairs are 0. Your bond pairs 4, lone pair 1, 3, 2, here 2, here 3. Understand? So students here, example for this type of compound AB5 is PCl5. Okay. Next. Next. Square planar. For this type of molecule, AB4E, that is, yes, F4. Okay. Next, AB3E2. Methyl Cl F3. Okay. Next, AB2E3. HCF2. Okay, these are the examples. Next one is, that is AB6. This is also taken as AB5E. Okay, listen. AB6, AB5E, AB4E2, okay, AB3E3 and AB2E2, so E4. students, all these structures completely follows octahedral. So based on the example and the bond pair electrons, we can easily say which type of electrons they are going to form. So listen here. AB6, 6 bond pairs, 1. So instead of this, I hope you cannot see this. So I write here AB6, AB5E, AB4, E2. And here AB3, E3, AB2, E2. Same here, right? 6 bond pairs, 5 bond pairs, 4, 3, 2. Here 0 lone pair, 1 lone pair, 2 lone pair, 3 lone pair, and E4. That is 4 lone pair. So example for such type of compounds, one is SF6. Okay. Next, ClF5, HCl4, and XCF6. Etc. These are the examples. So students, remember this. What I am telling is, this is the shape of the molecules or a type of the molecules. If AB2 type, AB3 type, this chart is very important for what is it? NEET also as well as theory also. Remember, any one structure is compulsory. What I am telling is the 5 theories are there: Lewis concept, valence shell, electron pair repulsion theory, VBT, hybridization, MOT. Among all these theories, understand? So the structures and their shapes, their type of molecule is very important, and the most often questions is structures only. Okay, so in that I'll just rub this between this. Okay, that is structure and the number of bond pair and number of lone pair, and I'll just take the example there, and I will tell you how to find out type of the molecule and how to find out the shape of the molecule. Okay, so I'll do one reminding, you do it yourself. Students, type of the molecule and shape is very important for people. Okay, so initially I'll go with BeCl2. So remember how to find out type of a molecule. Okay, this is valence electron, minus number of bonded electrons, valence electron minus number of bonded electrons divided by 2. Okay, valence electrons, number of bonded electrons divided by 2. So students, I'll take the example BeCl2 here. So this is the central metal atom. For that, we need to write the what is it? So here I'll take another one, CO2 also. Later I will write. So BeCl2 is there. Okay, so students, central metal atom is beryllium and its atomic number is 4. Configuration is 1s2, 2s2. This is valence shell, means 2 electrons are there. Okay, valence electrons are 2, number of bonded electrons 2, divided by 2, that is 0. This one is what? Electron pair. And number of electron pair, that is E. Okay, this is how to calculate. 0 electron pair is there. So students, remember, this is A molecule, this one is B2, there is no E. So the type of the molecule is AB2. From this formula, you can calculate electron pair E. The central metal atom is A, the bonded atoms are B. Here how many electrons you will get, that is E. Here 0 electron pair means the type of the molecule is AB2. So what is the shape of the AB2 molecule? I wrote here, that is linear. Okay, then this BCl2 is in linear shape. Understand? Okay. So next. MgCl2. So your Mg atomic number is 12. Of course, beryllium, magnesium, those all belongs to what? Second group only. So valence electron is 2. If you want to write, you can write 1s2, 2s2, 2p6, 3s2. So this is the valence shell. You know that. Which is the greater number of n value, that is the last shell. Here 2s to be completed, after 2s 3s is there. So that is the valence shell. So here 2 electrons are there. Means according to this, number of electron pair is equal to valence electron is 2. How many are bonded here? 2. So divided by 2 means 0 electron pair. This is also molecule of AB2. A is this, B is this. AB2 means linear in shape, that is MgCl. And also students, this is also tells about the bond angle between them. So here the bond angle is 180 degree. So initially I'll write, before going to explain this, I'll write some structures, standard structures, you just note down. Okay? Linear. Okay? Bond angle is 120 degree. Next. So here in the triangular, the bond angle is 120 degree. In between this pyramidal and this bond angle is 90 degree. Two types of angles are there. Next, last one is octahedral. Here A type. So students, here the bond angle between all them is 90 degrees. This is the standard structures. You need to know this because you may get an idea how to write the structures, where to write the bond pairs, where to write the load pairs. Understood? Linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral. Standard structure only I know. So students remember here. So if in this case, if you only one lone pair is there, I said square planar. Okay. So when the examples came, I'll explain the structures. Okay. Thank you. So AB2 type I already explained. Now AB3 type. So I will explain any two structure, how to find out the type of a molecule. So listen. So another one structure is BF3. Then this is the central metal atom B. Sorry. You write in the form AB3. Okay, now we should find out electron pair. What is the formula? Number of electron pair is equal to valence electron of boron. So students, boron, you need to remember the valence electron. Atomic number is 5, that is 1s2, 2s2, 2p1. Here, these two is the valence shell because their n value is same. 2s, 2p. So total 2 plus 1 is 3 electron. Minus, how many are bonded here? 3. Divided by 2. So 0 by 2 means 0. There is no electron pair means the molecule is AB3 type. If it is AB3 type, shape of the molecule is triangular or trigonal planar. Triangular or trigonal planar. Next, in the place of B, this is there, this is the structure and the bond angle between them is 120 degree. Later I will explain what is bond length, bond order, bond angle, everything. Just remember this. Next, this one, AlCl3. So students, here I take the second example. AlCl3. So aluminium atomic number is 13. Configuration 1s2, 2s2, 2p6, 3s2, 3p1. Listen here. Initially in boron the configuration is 1s2, 2s2, 2p1. Here this is the greater n value. So we take this one as a valence shell. But here, 1s completed, 2s, 2p completed. This one is the greater number. We are considering this one as a valence shell. Here 2 plus 1, 3 electrons are there. Similarly, electron pair is 3 electrons minus the bonded here is what? 3 divided by 0, that is 0 electrons divided by 2. So 0 by 2 means 0. So students, here Al is A, Cl is B3, AB3 type molecule because there is no lone pair electron. The shape of AB3 molecule is trigonal planar. You take Al here, same Cl, triangular structure, and the bond angle is 120 degree. Okay, so this is how to find out the electron type of AB3. The next comes AB2E. Listen. This one. SO2. Okay? So listen here. SO2. Sulfur is there. Sulfur atomic number is 16. Initially you write the type of the molecule. Okay? And listen students, this AO2. Wherever oxygen is there, that is double bonded. Remember that. SO2 structure, it may be like this. You need to remember that wherever oxygen is there, double bond. Wherever hydrogen is there, single bond. Fluorine, single bond. That too also you have to remember. Because your oxygen is there, if you take single bond, you won't get the correct answer. Listen here, atomic number 16, configuration 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so here this is the valence electron. Understand? So students, here in this structure, because the sulfur is divalent, so oxygen is divalent. It has the capacity to form 2 bonds. Now here, so number of electron pair. Okay, so here valence electron is 6. Number of bond pair of electrons here is 4. Divided by 2. That is how much? 2 by 2 means 1. Means the molecule here is A. How many atoms are bonded means 2. So 1 electron pair. We are not considering how many bonds. We are considering how many atoms. Here of course sulfur is bonded with oxygen in a multiple bond, double bond. Even though here B is an atom, not a bond. Don't confuse. S double bond O, double bond O. So we are considering only atoms, not these bonds. Don't get confused. We are not considering whether it is a single bond, double bond or a triple bond. We are considering only the number of atoms. A is the central metal atom, B2 is the bonded atoms. 1 electron pair we get AB2E. So students here, if sulfur is there, listen. Sulfur. Okay, AB2E, of course oxygen is bonded like this in the linear form, and here the lone pair electrons are there. You know, in the yesterday's class I wrote lone pair repulsion is greater than lone pair bond pair repulsion. Greater than bond pair repulsion means this there is a repulsion between lone pair and bond pair. So then what happens? Here the 2 electrons are there like this. Okay. So the 2 atoms are there. Due to this lone pair of electron, they repel like this. Are you getting? They are exactly like this. Are you getting? Okay, they are exactly like this. So due to the repulsion means they are like this. Means which angle it is? I hope you can see easily. So now what happens is due to this repulsion between them, it is like this. Okay. Now the bond here they form same triangle structure. But remember, here the bond angle between these two is less than 120 degree. Why? So if the repulsion is more, bond angle decreases. Like how? Listen, here the 2 atoms are there. They are in this manner. Bond angle is more. If they are like this, exactly 90 degree. Okay, if they are like this, 120 degree. When they get closer, the bond angle decreases of course. Means repulsion is more, bond angle is less. The bond angle decreases. Understand? So here you can easily write the bond angle is 180 degree. Similarly, I didn't explain CO2 here. Remember, I'll take CO2 here. Okay, carbon having valency, so electron pair we need to check. Carbon having valency 4. Of course, the bonded atom here is also 4, that is 0. Sorry, by 2, so 0 by 2 means 0. 0 electron pair is there. So this carbon is A and oxygen is B 2 times. So this is written in a linear manner. No matter whether it is a single bond or a double bond. Similarly, we will do it for oxygen, O3 molecule. Okay, oxygen is here. Its atomic number is 8. Configuration 1s2, 2s2, 2p4. So this is the valence. So O3 molecule in that this oxygen is bonded to this atom like this. Okay. Remember here, this one is having plus charge, this one is having minus charge. Or you simply take single. Okay, like this we take. So students here, listen, here we already assigned a formal charge here. You know that how to assign. Okay. So here the number of electrons on this atom, how to calculate electron pair means here the valence electrons are 6. Okay, and at the same time the bonded electrons of this oxygen atom is only 2. 4 divided by 2, that is 2 by 2, that is 1 electron pair. Remember why I am taking 4 here. Listen, in the last class, while forming or framing the Lewis concept, or while designing the Lewis structure, I explained. So in this bond, the electrons of this oxygen is involved instead of this. I told you. Understand? So that's why. So it is 1 electron pair. Then the molecule is A. 2 oxygen atom. 1 oxygen atom is A. 2 oxygen atom is B2. 1 electron pair, that is E. So here, like this lone pair electron is there. If it is bonded like that, the bond angle is less than 180 degree because of lone pair bond pair repulsion. Remember, this is very important. Why the bond angle is less compared to the actual bond angle, due to which type of repulsion? Lone pair repulsion or lone pair bond pair repulsion, you need to write. Okay, so this is all about what? AB2, AB3 and AB2 E-type molecule. So the next one is AB4 type molecule. Okay, AB4 type molecule. So I will take this CH4 first. So students here, CH4 is there. Okay, from here only we can easily get how many bonds are there. Here, the atomic number of carbon is 6. Configuration 1s2, 2s2, 2p2. This is the valence shell. So students here, how to find out the electron pair? So number of valence electron of carbon is 4. How many are bonded here? 4 divided by 2. So 0 by 2 means 0 electron pair. So students, carbon is A here and hydrogen is B here. How many times? 4 times. AB4 type molecule means the structure is tetrahedron. Okay. Now, how to write the tetrahedral structure? So, carbon is here. 1, 2, 3, 4 bonds are here. H, H, H and H. So, the bond angle is 109.5 degrees. Okay. So, this is one structure. Next you take second one, that is SiCl4. So students, silicon atomic number is 16, configuration is 1s2, 2s2, 2p6, 3s2, 3p2. Not 16, silicon is 14. Okay, now this is the valence. So the number of electron pair. Valence electrons are 4. Bonded here is how much? 4 divided by 2. So 0 by 2 is 0. So silicon here is A and this chlorine is B 4 times. There is 0 electron pair means AB4 type molecule. If it is AB4 type, then the structure is of course tetrahedron. How to write? So silicon is here. Okay. 1, 2, 3, 4 bonds in a tetrahedron form. The 4 atoms are Cl here. And the bond angle between them is 109.5 degree. Actually that is 109 degree 28 minutes, but this is enough. 109.5 degree. So similarly, you may write it for NH4 plus also. So listen, NH4 plus. So consider nitrogen its atomic number is 7. Okay, then write the electronic configuration, that is 1s2, 2s2, 2p3. So students, they mention NH4 plus. So here plus charge means one electron is less. N with the plus charge means one electron is less. Then the configuration 1s2, 2s2, 2p2. Understood? So now here, of course, the number of, how to find out the electron pair here is, the number of valence electron here is, how much? So this is the valential 4. So this is the bonded, divided by 2. 0 by 2 means 0. The molecule is AB4 type. So students, nitrogen is here. So this is tetrahedrally bonded like this, 109.5 degree. This is H, 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 H. So this complete nitrogen gets positive charge. This is how to find out the structure of the molecules. Okay. So in the tomorrow's class, we will continue with the next structure. Remember, what is the work for you people? You just do this, you just apply this BSc PR theory for these remaining molecules. At least these two you do. AB3 E type, AB2 E2 type. Okay, thank you.